Hello student, today we'll discuss about the mode of the heat transfer. This topic is covered in the heat transfer chapter of the thermal engineering 1 subject. At the end of this lecture, you will be able to understand the various modes of the heat transfer, also to identify the basic laws of the heat transfer and to know the application of the heat transfer. Now mode of the heat transfer. There are three modes of the heat transfer. One is known as the conduction mode of the heat transfer. Second one is known as a convection mode of the heat transfer, and third one is known as a radiation mode of the heat transfer. First we talk about the conduction mode of the heat transfer. As shown in the figure, there is a one container is there which is heated at the bottom side. So heat is transferred through the handle. So this type of the heat transfer is known as a conduction mode of the heat transfer, where there is a direct contact. There is a direct contact. So that mode of the heat transfer is known as a conduction mode of the heat transfer. Also you can take one metal rod. When metal rod is heated at the one end at a higher temperature, so heat is transferred to the another end. That is also known as a conduction mode of the heat transfer. Now second one is known as a convection mode of the heat transfer. Same figure is there, but the difference is there is a fluid. If we take, there is a water is there, and it is heated at the bottom side. So water temperature is increased. The reason behind this heat transfer is known as a convection mode of the heat transfer. So convection mode of the heat transfer is between the surface, solid surface, and the fluid in contact. So that type of the heat transfer is known as a convection mode of the heat transfer. So in this case, energy is transferred by the mass motion of the molecules. That is a molecular movement is there. Then the third one is known as a radiation mode of the heat transfer. In the radiation mode of the heat transfer, we take one example. This is the fire is there. So in that, you are not in direct contact of the fire, but at a certain distance you will feel the heat. So that is the reason of the radiation mode of the heat transfer. In this case, there is a electromagnetic waves are there. There is a electromagnetic waves are there which transfer the energy from the source to the certain distance. So that type of heat transfer is known as a radiation mode of the heat transfer. The another classical example of the radiation mode of the heat transfer is that is the sun. So sun gives the heat to the earth through the electromagnetic waves. So that type of the uh, heat transfer is known as a radiation mode of the heat transfer. So in that case, there is a no contact between the sun and earth. So heat is directly transferred to the earth through the electromagnetic radiation or electromagnetic waves. So that type of the heat transfer is known as a radiation mode of the heat transfer. Once again, there is a conduction mode of, there is a direct contact. Here is fluid is in picture, and here is a electromagnetic waves are in picture. So there are the three mode of the heat transfer: conduction, convection, and radiation. Now next is the basic concept of the heat transfer with the help of the basic laws. So to understand the conduction mode of the heat transfer, as we already discussed the one example, and another example, it is heat transfer through the metal rod. But each and every mode of the heat transfer is governed by the basic laws. So first is conduction, which governed by the one law which is known as a Fourier's law. So Fourier scientists developed this law by doing the number of the experiment, and develop the one equation which is already written, that is a q is equal to minus ka t1 minus t2 divided by x. So when we want to find the heat transfer q through the conduction mode of the heat transfer, at that time we need to operate the Fourier's law. In the Fourier's law, there is an equation, there is a k is there. K is the thermal conductivity of the certain material. Then A is the area, T1 and T2. T1 and T2 is the temperature. One is at a higher temperature, another is a lower temperature. So when there is a contact, so that temperature is the T1, and another temperature is a T2. Now divided by x, x is a thickness of that particular material. So that is a conduction. Again, basic law is a Fourier's law, and the equation is a Q is equal to minus K T1 minus T2 divided by x. Second is a convection. In the convection mode of the heat transfer, as we discussed, the heat transfer between the solid surface and the fluid in motion. So in the convection mode of the heat transfer, there are the two types. One is a forced convection and another is a natural convection. In the forced convection, there is a mechanical device is used. As in the picture, there is a fan is there. So fan is used to transfer the heat between the air and the solid surface. So that type of heat transfer is related to the forced convection because we are using the mechanical device fan. If we are not using any mechanical device like uh, in this picture, that is known as a natural convection. That is known as a natural convection. So when the mechanical device is used in the convection, like not only the fan, if we have the uh, uh, like pump for the fluid, that is also known as a forced convection. And in for the when we are not using any mechanical device, then it is known as a natural convection. The basic law for the convection mode of the heat transfer is the Newton's law of the cooling, and the equation is equal to Q is equal to HA T1 minus T2, where Q is the rate of heat transfer, H is a convective coefficient, A is the once again area, T1 and T2 is the corresponding temperature. Now next is the radiation mode of the heat transfer. As discussed, the radiation mode of the heat transfer is heat transfer through the electromagnetic radiation, and the basic law governed by the Stephens-Boltzmann law. So Stephens-Boltzmann scientist has developed this law, which is related to the EB is equal to sigma A T raised to 4, where EB is the emissive power, where the sigma is the Stephens-Boltzmann's constant, A is the area, and T is the temperature. So that is about the Stephens-Boltzmann's law for the radiation mode of the heat transfer. Now if we summarize whole discussion of the various mode of the heat transfer, it is very much important for the any interview or any exams. So you can learn this various mode of the heat transfer through this table, where it cover the example, basic law and equation. How this equation has been come, we will discuss later on. That first is a conduction as the Fourier's law, second is the convection, it is a Newton's law of the cooling, and third one is the radiation, the law is the Stephens-Boltzmann's law, and the different equations. So it is really important for the any mechanical engineer, not only the mechanical, chemical engineer is also involved in the heat transfer picture. There are the number of the devices is used, like the heat exchanger, boiler, condenser, cooling tower, where the heat transfer knowledge is very much important to identify its efficiency and all the characteristics of particular devices. So heat transfer is very much important, and these are the three mode of the heat transfer, that is conduction, convection and radiation. Thank you.